Okay, so I each gave you 5 teams to order and put the home versus away. Okay? So on this column, actually, yeah, let's put it over here. We're going to hit, well, yeah, we'll put it right here. That's fine. Go home average. And then the next column, away average. Okay. So let's calculate how well the Arizona defense does at home. So remember, these are metrics on how well they fit what they were predicted to do. Okay? So let's go equals, and again, I just usually type it average, parentheses, and now let's select columns C through, I can't see it, J, is that right? Here, return. Okay, what's that? Say it again. Oh, so what I would do is just, when you're at this point here, take just put it in the first cell that you want and then just drag it over. So it's going to say C4 and then it's a colon J4. And just hit return. Okay, let's do the away. Equals average, parentheses. Okay, this time columns L through S. Hit return. Okay. Now let's drag them down for the rest of yours. So the 5 that you did, let's just drag this down. Okay. Any big differences here? If we look at your own, if we look at Arizona, they seem to do better. Their defense does better at home than away. Here they're making the team score less, less than what they normally score by like 6 points. Almost 7. When they're away, the defense is still doing good. It's doing better than we predicted, but not as well, right? The question is this real? And this is where we're going to find out. We can look at some of these. This one's a good one too. Atlanta offense, if we look here, they typically score 6 more points at home than we would expect. But when they're away, they score 3 less. Here's what we have to do now. But if you look at some of this data, right, basically here's what we're going to do is we're going to make these anthills out of both of these. We're basically going to turn this into normal distribution and see how much they overlap. If they overlap, I'm going to say less than 10%. I'm going to call that a real effect. Is everybody with me? Cool. Okay, so now here's where we do the famous Guinness Brewery t-test. Let's go t-test, then we'll write p-value. Anybody know what P stands for in this instance? And don't say urine, BT. You always got some smart comment. What do you think P stands for? Yes, who said that? Connor. Thank you. Con man. Actually, I'm going to have to change your name to the Condor. You swoop in and you get the right answer. That's very good. All right. So here's what we're going to do is now we're going to set up our t-test. This is how we're going to determine whether there's a true effect there. Whether those anthills that represent the home games versus the away games are very different. How much do they overlap? And that's what we're going to calculate right now. So go to the function and find t-test. You can search for it if you'd like. T-test. Everybody see it? Got it? Double click on that. Okay. You're going to see t-test, and you're going to see array 1, array 2, tails, and type. What do you think array 1 and array 2 refer to? What are we going to use for those? Home and away, absolutely. What do you think the tails means? Yeah, totally. Pre-med. Bonus points. Very nice. If I had my Partech t-shirts that I was supposed to give away, you would get one right now. Absolutely. It's that the t-test, the tails is basically, do we want to test both sides of that bell curve, or do we want to test one side? So if we want to test whether, the overlap on both sides of that big hill, then it's a two-tail. In this instance, I just want to know if one is greater or less than the other, so I'm just going to hit 1. And then we'll type. We don't have to worry about that one. So let's put in the array stuff. So array 1 is going to contain columns C4 through J5 or J4. Okay, I've selected all the home games for that particular team. Okay, I go to array 2. Select same row, L, M. So these are the two, we're going to make two basically anthills from these things. Okay. Now I'm going to say I want one tail. I just want to know if one is different than the other. Okay. Now for type, we'll go in this a little differently, but basically, are the data similar? If they're kind of similar and you expect the variation to be kind of the same, the kind of spread, you're going to put 2. If you're comparing very different things that have a different, like the widths of those anthills, you would put 3. Let's just put 2 for now. So we got one tail in type 2. Okay, hit return. Okay. Here is our p-value. What do you think this value represents? Yep. And how much are they overlapping? 9%, 10%. That's not bad. So basically what's that saying is there's a 10% chance there's really no difference. That the way they played, maybe they played like really bad teams at home and really good teams. You always have that probability. So that maybe it's just kind of a artifact of the data itself. But in my world, I say 10% is pretty significant. So every time from now on, Arizona defense, I am going to use their home game, their average of their home games, rather than the average of their away games. Or I'm basically going to use the average of both of these. So you can drag this all the way down. So drag this all the way down to all your stuff. Did you get any ones that were less than 10%? Yeah, who'd you get? Chicago offense. And I bet it's a bad thing, right? 9.4%. But so what does that mean? Where do they play better, at home or away? So look at the home average here, right? So basically, I know that there's a 10% chance that these are, these are true. The 90% chance they're truly different, basically. If I look at the scores, my average that I computed, home versus away, where's my biggest effect? It's a home, right? So this is really where they're going to have like their biggest effect. So basically, what this means is Arizona defense statistically plays better at home. Their defense does, because they typically allow about 7 points less the other team to score than you would predict. There's a slight effect here. This might say that maybe the Atlanta offense plays better at home. There's a 12% chance of that. Does everybody see what we just did? What you just did was pretty amazing. Like you did. This is the peanut butter and jelly of statistics as a t-test. And everything I'm going to teach you is kind of going to come off of this. In a way, we probably shouldn't be doing a t-test. We should be doing something else, but a t-test works fine. All right. So let's go and get out the thing you downloaded, because I've done this. Okay. Where's my... Oh. So you have this one, right? Okay. So I have done this, and look what I did. I color-coded it as well. So I did this for all the teams. So basically what you're going to do is you're going to do this. If you want this sheet, you can do this for yourself. So basically in the remaining time, I want you to set up, I want this. So go up to column S. Make this your average home, average away, and this will be t-test, p-value. Okay, so basically you're going to set this up, but let's look at the one I already have. I should have saved it, but hold on a sec. Where did I put it? I got it on my desktop. Hold on. Wait a minute. Oh, here I got it up here. No. I'm trying to find it. Okay, actually, go ahead and keep working on yours. So get that. Basically, do exactly what you did. Do it for all the games. So find the average of the home team, average of the away team, and then do the t-test. And then once you're done, we'll see if it looks like mine. So remember, all you got to do is do the top row for each of those columns and then just drag everything down. Everybody understand that, right? That's going to save you a ton of time. All right, and I'll work on finding the one that I completed.